All right, on to Unit 7, Part A through C. Differential equation. A is the amount of salt in a vat, and T is time in minutes. This is our differential equation in terms of A, and we have an initial value when time is 10 minutes, the amount is 50. A says write an equation of the line tangent to A at 10, t equal to 10, use the tangent line. Okay, so let's find the equation line tangent curve at t equals 10. Okay, so we need two things for equation line, slope and y-intercept, but we already have an ordered pair 10 comma 50. So now we just have to find the slope at that point. So our slope is right here, dA dt, but our input is a, not t. So we can just plug in 50 for a, because it's a function written in terms of a. So dA dt of 50 gives you 6 minus 0.02 times 50. 6 minus 1 is 5. All right, so that's our slope. Y equals mx plus b. Slope is 5. Our ordered pair is 10 comma 50. So b ends up being 0. So the equation line is y equals 5x. So in this case, it's a equals 5. T would be our answer. Use the tangent line to approximate the number of pounds of salt. So find A when T is 12. So it'd be 60 pounds of salt. And that would be part A. Part B. Okay, so part B says show that A of T that equation satisfies the differential equations dA dt, the one we used up above, with the initial condition still 10 comma 50. All right, so does it satisfy it? So let's first check to see if it goes through the point 0 or 10 comma 50. So if we plug in 10 for T, let's see, probably a calculator problem. Actually, we end up getting 50 because that's e to the 0. So we get 50. So it checks. At least that it goes through the ordered pair. Now let's find the derivative of that. So dA dt equals, that's a constant. The negative 250 floats times the derivative of the exponent, which is negative 0.02. So negative 0.02 times 250 is 5. So it's 5e to the 0.2 minus 0.02t. Okay, so that's the derivative of that one in terms of t. We have this in terms of a. Let's see if we can get it in terms of t and see if they're the same thing. Okay, so d dt equals 6 minus 0.02 times a, which we're seeing. So there it is in terms of a. We're going to plug our new a in there and see if it's the same thing. So 6 minus 0.02, 6 plus 5e to the 0.2 minus 0.02t. So we get 5e to the 0.2 minus 0.02t. So this also checks. The derivatives are the same and it goes through the same or the order pair 10, 50. So we're good. If you still want clarification, maybe I'll make up a problem like this after I do letter C. So on to letter C, and then if you want to keep watching, you can. Letter C says, okay, so they give us dH dt. H is measured in meters, T is in minutes. This is the height of the vat. It's draining out. K is just a constant. It says the depth is 16 meters when time is 0. They also tell us that when time is 30, the height is 4. A couple initial values. We're trying to write H of T in terms of T. All right, so we're going to start by solving this differential equation by separating the variables. The dependent variable is H, so we need to move the H factor over here. So we have dH dt times 1 over square root of H equals negative K. And we integrate with respect to T. On the left, we'll have 1 over square root of H dH, integral negative K dt. So that's H to the negative 1/2. So antiderivative will be H to the positive times 2. And then equals negative KT plus C. All right, so now we look at what's our initial value. Well, we know that when time is 0, H is 16. So 2 square root of 16 equals negative K times 0 plus C. So 2 times 4, so C equals 8. All right, so now we have 2 square root of H equals negative KT plus 8. And then to find out what K is going to be, we need our additional initial value. T is 30 when H is 4. So K is 2/15. All right, so we have our answer. It's this one right here. 2 square root of H equals negative 2/15 T plus C is 8. Now we just have to solve for H. So divide by 2. Negative 1/15 T plus 4. Square both sides. And there's our H of T. All right. So just to give you an idea, so this is related to part B, just to understand what we're actually doing. Let's say that f of x is x cubed plus 4, and df dx equals 3 times f minus 4 to the 2/3. And let's say our initial value is 1, 5. See if this satisfies this differential equation. So to do that, first we want to plug in 1 and see if it gives you 5. I plug in 1, I get 1 cubed plus 4 is 5, so that works. Remember, f of x equals x cubed plus 4. So now let's do df dx equals 3x squared. All right, so we have our derivative. Now let's see if that's the same as this derivative. So our differential equation, it's in terms of f, not x. So let's replace our f with x cubed plus 4. And minus 4 to the 2/3. So we get 3 times x cubed to the 2/3. X cubed to the 2/3 is x squared. And we get df dx equals 3x squared. So it verifies to be a solution.